A computer monitor or a computer display is an electronic visual display for computers. A monitor usually comprises the display device, circuitry, casing, and power supply. The display device in modern monitors is typically a thin film transistor liquid crystal display or a flat panel LED display, while older monitors used a cathode ray tubes. It can be connected to the computer via VGA, DVI, HDMI, DisplayPort, Thunderbolt, LVDS or other proprietary connectors and signals. Originally, computer monitors were used for data processing while television receivers were used for entertainment. From the 1980s onwards, computers have been used for both data processing and entertainment, while televisions have implemented some computer functionality. The common aspect ratio of televisions and computer monitors has changed from 4:3 to 16:10 to 16:9. History. Early electronic computers were fitted with a panel of light bulbs where the state of each particular bulb would indicate the on/off state of a particular register bit inside the computer. This allowed the engineers operating the computer to monitor the internal state of the machine. So this panel of lights came to be known as the monitor. As early monitors were only capable of displaying a very limited amount of information, and were very transient, they were rarely considered for program output. Instead, a line printer was the primary output device, while the monitor was limited to keeping track of the program's operation. As technology developed, it was realized that the output of a court display was more flexible than a panel of light bulbs, and eventually, by giving control of what was displayed to the program itself, the monitor itself became a powerful output device in its own right. Technologies. Multiple technologies have been used for computer monitors. Until the 21st century, most used cathode ray tubes, but they have largely been superseded by LCD monitors. Cathode ray tube. The first computer monitors used cathode ray tubes. Prior to the advent of home computers in the late 1970s, it was common for a video display terminal using a court to be physically integrated with a keyboard and other components of the system in a single, large chassis. The display was monochrome and far less sharp and detailed than on a modern flat-panel monitor, necessitating the use of relatively large text and severely limiting the amount of information that could be displayed at one time. High-resolution court displays were developed for specialized military, industrial and scientific applications, but they were far too costly for general use. Some of the earliest home computers were limited to monochrome court displays, but color display capability was already a standard feature of the pioneering Apple II, introduced in 1977, and the specialty of the more graphically sophisticated Atari 800, introduced in 1979. Either computer could be connected to the antenna terminals of an ordinary color TV set or used with a purpose-made court color monitor for optimum resolution and color quality. Lagging several years behind, in 1981 IBM introduced the color graphics adapter, which could display 4 colors with a resolution of 320 by 200 pixels, or it could produce 640 by 200 pixels with 2 colors. In 1984 IBM introduced the Enhanced Graphics Adapter, which was capable of producing 16 colors and had a resolution of 640 by 350. By the end of the 1980s, color court monitors that could clearly display 1024 by 768 pixels were widely available and increasingly affordable. During the following decade, maximum display resolutions gradually increased and prices continued to fall. Court technology remained dominant in the PC monitor market into the new millennium, partly because it was cheaper to produce and offered viewing angles close to 180 degrees. CRTs still offer some image quality advantages over LCD displays, but improvements to the latter have made them much less obvious. The dynamic range of early LCD panels was very poor, and although text and other motionless graphics were sharper than on a court, An LCD characteristic known as pixel lag caused moving graphics to appear noticeably smeared and blurry. Liquid crystal display. There are multiple technologies that have been used to implement liquid crystal displays. Throughout the 1990s, the primary use of LCD technology as computer monitors was in laptops where the lower power consumption, lighter weight, and smaller physical size of LCDs justified the higher price versus a quart. Commonly, the same laptop would be offered with an assortment of display options at increasing price points. Monochrome, passive color, or active matrix color. As volume and manufacturing capability have improved, the monochrome and passive color technologies were dropped from most product lines. Tft Lcd is a variant of LCD which is now the dominant technology used for computer monitors. The first standalone LCD displays appeared in the mid-1990s, selling for high prices. As prices declined over a period of years, they became more popular, and by 1997 were competing with quart monitors. Among the first desktop LCD computer monitors was the ASO L66 in the mid-1990s, the Apple Studio display in 1998, and the Apple Cinema display in 1999. In 2003, Tft Lcds outsold CRTs for the first time, becoming the primary technology used for computer monitors. The main advantages of LCDs over quart displays are that LCDs consume less power, take up much less space, and are considerably lighter. The now common active matrix Tft Lcd technology also has less flickering than CRTs, which reduces eye strain. On the other hand, quart monitors have superior contrast, have superior response time, are able to use multiple screen resolutions natively, and there is no discernible flicker if the refresh rate is set to a sufficiently high value. LCD monitors have now very high temporal accuracy and can be used for vision research. Organic light-emitting diode. Organic light-emitting diode monitors provide higher contrast and better viewing angles than LCDs, but they require more power when displaying documents with white or bright backgrounds. In 2011, a 25-inch OLED monitor costs $7,500, but the prices are expected to drop. Measurements of performance. The performance of a monitor is measured by the following parameters. Luminance is measured in candelas per square meter. Aspect ratio is the ratio of the horizontal length to the vertical length. Monitors usually have the aspect ratio 4:3, 5:4, 16:10 or 16:9. Viewable image size is usually measured diagonally, but the actual widths and heights are more informative since they are not affected by the aspect ratio in the same way. For CRTs, the viewable size is typically 1 in smaller than the tube itself. Display resolution is the number of distinct pixels in each dimension that can be displayed. For a given display size, maximum resolution is limited by dot pitch. Dot pitch is the distance between subpixels of the same color in millimeters. In general, the smaller the dot pitch, the sharper the picture will appear. Refresh rate is the number of times in a second that a display is illuminated. Maximum refresh rate is limited by response time. Response time is the time a pixel in a monitor takes to go from active to inactive and back to active again, measured in milliseconds. Lower numbers mean faster transitions and therefore fewer visible image artifacts. Contrast ratio is the ratio of the luminosity of the brightest color to that of the darkest color that the monitor is capable of producing. Power consumption is measured in watts. Delta E. Color accuracy is measured in delta E. The lower the delta E, the more accurate the color representation. A delta E of below 1 is imperceptible to the human eye. Delta S of 2 to 4 are considered good and require a sensitive eye to spot the difference. Viewing angle is the maximum angle at which images on the monitor can be viewed, without excessive degradation to the image. It is measured in degrees horizontally and vertically. size on two-dimensional display devices such as computer monitors. The display size or viewable image size is the actual amount of screen space that is available to display a picture, video or working space, without obstruction from the case or other aspects of the unit's design. The main measurements for display devices are width, height, total area and the diagonal. The size of a display is usually by monitor manufacturers given by the diagonal, i.e., the distance between two opposite screen corners. This method of measurement is inherited from the method used for the first generation of court television, when picture tubes with circular faces were in common use. Being circular, it was the external diameter of the glass envelope that described their size. Since these circular tubes were used to display rectangular images, the diagonal measurement of the rectangular image was smaller than the diameter of the tube's face. This method continued even when cathode ray tubes were manufactured as rounded rectangles. It had the advantage of being a single number specifying the size, and was not confusing when the aspect ratio was universally 4:3. With the introduction of flat panel technology, the diagonal measurement became the actual diagonal of the visible display. This meant that an 18-inch LCD display had a larger visible area than an 18-inch cathode ray tube. The estimation of the monitor size by the distance between opposite corners does not take into account the display aspect ratio, so that, for example, a 16:9 21-inch widescreen display has less area than a 21-inch 4:3 screen. The 4:3 screen has dimensions of 16.8 in x 12.6 in and area 211 square in, while the widescreen is 18.3 in x 10.3 in, 188 square in. Aspect ratio. Until about 2003, most computer monitors had a 4:3 aspect ratio and some had 5:4. Between 2003 and 2006, monitors with 16:9 and mostly 16:10 aspect ratios became commonly available, first in laptops and later also in standalone monitors. Reasons for this transition was productive uses for such monitors, i.e., besides widescreen computer gameplay and movie viewing, other word processor display of two standard letter pages side by side, as well as CAD displays of large-size drawings and CAD application menus at the same time. In 2008, 16:10 became the most common sold aspect ratio for LCD monitors, and the same year 16:10 was the mainstream standard for laptops and notebook computers. In 2010, the computer industry started to move over from 16:10 to 16:9 because 16:9 was chosen to be the standard high-definition television display size, and because they were cheaper to manufacture. In 2011, non-widescreen displays with 4:3 aspect ratios were only being manufactured in small quantities. According to Samsung, this was because the demand for the old, square monitors has decreased rapidly over the last couple of years, and I predict that by the end of 2011, production on all 4:3 or similar panels will be halted due to a lack of demand. Resolution. The resolution for computer monitors has increased over time, from 320 by 200 during the early 1980s, to 800 by 600 during the late 1990s. Since 2009, the most commonly sold resolution for computer monitors is 1920 by 1080. Before 2013, top-end consumer products were limited to 2560 by 1600 at 30 in, excluding Apple products. Apple introduced 2880 by 1800 with Retina MacBook Pro at 15.4 in on June 12, 2012, and introduced a 5120 by 2880 Retina iMac at 27 in on October 16, 2014. By 2015, all major display manufacturers had released 3840 by 2160 resolution displays. Additional features. Power saving. Most modern monitors will switch to a power saving mode if no video input signal is received. This allows modern operating systems to turn off a monitor after a specified period of inactivity. This also extends the monitor's service life. Some monitors will also switch themselves off after a time period on standby. Most modern laptops provide a method of screen dimming after periods of inactivity or when the battery is in use. This extends battery life and reduces wear. Integrated accessories. Many monitors have other accessories integrated. This places standard ports within easy reach and eliminates the need for another separate hub, camera, microphone, or set of speakers. These monitors have advanced microprocessors which contain codec information, Windows interface drivers and other small software which help in proper functioning of these functions. Glossy screens. Some displays, especially newer LCD monitors, replace the traditional anti-glare matte finish with a glossy one. This increases color saturation and sharpness, but reflections from lights and windows are very visible. Anti-reflective coatings are sometimes applied to help reduce reflections, although this only mitigates the effect. Curved designs. In about 2009, NEC, Alienware together with Ostender Technologies were offering a curved 43-inch monitor that allows better viewing angles near the edges, covering 75% of peripheral vision. This monitor had 2880 by 900 resolution, LED backlight and was marketed as suitable both for gaming and office work, while for $6,499 it was rather expensive. As of 2013, the monitor is no longer available. Ostender Technologies is no longer pursuing curved monitor technology. Directional screen. Narrow viewing angle screens are used in some security-conscious applications. 3D. Newer monitors are able to display a different image for each eye, often with the help of special glasses, giving the perception of depth. Active shutter. Polarized auto-stereoscopic. A directional screen which generates 3D images without headgear. Touch screen. These monitors use touching of the screen as an input method. Items can be selected or moved with a finger, and finger gestures may be used to convey commands. The screen will need frequent cleaning due to image degradation from fingerprints. Tablet screens. A combination of a monitor with a graphics tablet. Such devices are typically unresponsive to touch without the use of one or more special tools. Pressure. Newer models, however, are now able to detect touch from any pressure and often have the ability to detect tilt and rotation as well. Touch and tablet screens are used on LCD displays as a substitute for the light pen, which can only work on CRTs. Mounting. Computer monitors are provided with a variety of methods for mounting them depending on the application and environment. Desktop. A desktop monitor is typically provided with a stand from the manufacturer which lifts the monitor up to a more ergonomic viewing height. The stand may be attached to the monitor using a proprietary method or may use, or be adaptable to, a Video Electronics Standards Association (Vesa) standard mount. Using a Vesa standard mount allows the monitor to be used with an aftermarket stand once the original stand is removed. Stands may be fixed or offer a variety of features such as height adjustment, horizontal swivel, and landscape or portrait screen orientation. Vesa Mount. The flat display mounting interface, also known as Vesa Mounting Interface Standard or colloquially as a Vesa Mount, is a family of standards defined by the Video Electronics Standards Association for mounting flat panel monitors, TVs, and other displays to stands or wall mounts. It is implemented on most modern flat panel monitors and TVs. For computer monitors, the Vesa mount typically consists of 4 threaded holes on the rear of the display that will mate with an adapter bracket. Rack mount. Rack mount computer monitors are available in 2 styles and are intended to be mounted into a 19-inch rack. Fixed. A fixed rack mount monitor is mounted directly to the rack with the LCD visible at all times. The height of the unit is measured in rack units, and 8U or 9U are most common to fit 17-inch or 19-inch LCD displays. The front sides of the unit are provided with flanges to mount to the rack, providing appropriately spaced holes or slots for the rack mounting screws. A 19-inch diagonal LCD is the largest size that will fit within the rails of a 19-inch rack. Larger LCDs may be accommodated better, mount on rack, and extend forward of the rack. There are smaller display units, typically used in broadcast environments, which fit multiple smaller LCD displays side by side into one rack mount. Stowable. A stowable rack mount monitor is 1U, 2U or 3U high and is mounted on rack slides, allowing the display to be folded down and the unit slid into the rack for storage. The display is visible only when the display is pulled out of the rack and deployed. These units may include only a display or may be equipped with a keyboard, creating a KVM. Most common are systems with a single LCD display, but there are systems providing 2 or 3 displays in a single rack mount system. Panel mount. A panel mount computer monitor is intended for mounting into a flat surface with the front of the display unit protruding just slightly. They may also be mounted to the rear of the panel. A flange is provided around the LCD display, sides, top and bottom, to allow mounting. This contrasts with a rack mount display where the flanges are only on the sides. The flanges will be provided with holes for through bolts or may have studs welded to the rear surface to secure the unit in the hole in the panel. Often a gasket is provided to provide a watertight seal to the panel, and the front of the LCD will be sealed to the back of the front panel to prevent water and dirt contamination. Open frame. An open frame monitor provides the LCD monitor and enough supporting structure to hold associated electronics and to minimally support the LCD. Provision will be made for attaching the unit to some external structure or for support and protection. Open frame LCD displays are intended to be built into some other piece of equipment. An arcade video game would be a good example, with the display mounted inside the cabinet. There is usually an open frame display inside all end-use displays, with the end-use display simply providing an attractive protective enclosure. Some rack-mount LCD display manufacturers will purchase desktop displays, take them apart, and discard the outer plastic parts, keeping the inner open-frame LCD display for inclusion into their product. Security vulnerabilities. According to an NSA document leaked to Der Spiegel, the NSA sometimes swaps the monitor cables on targeted computers with a bugged monitor cable in order to allow the NSA to remotely see what's displayed on the targeted computer monitor. VANEC phreaking is the process of remotely displaying the contents of a CRT or LCD display by detecting its electromagnetic emissions. It is named after Dutch computer researcher Wim VANEC, who in 1985 published the first paper on it, including proof of concept. Phreaking is the process of exploiting telephone networks, used here because of its connection to eavesdropping.